Okay, this lesson should be fairly straightforward. The last one we looked at molar masses of just single atoms pulled off the periodic table. We use their masses in grams because those are equal to how many grams are in a mole. But we can do that with molecules just as easily. So our first example just says calculate the molar mass of potassium dichromate. And this formula is giving us 2 potassiums, 2 chromiums, and 7 oxygens. So we just need to look up the masses of all of these guys. 39.10 is going to be the potassium times 2. Chromium is 52 even. 2 decimal places is always going to be enough for any molar mass that you're looking at on the periodic table. That's pretty much the standard. And then oxygen is 16 even. You're going to start to memorize some of these the more that you go, times 7 of those. Add all of those up. You're going to get 294.20. Units on this are grams per mole. Okay, this is not something you generally have to show your work for. You're going to just be calculating molar masses very quickly moving forward because we're going to use them in stoichiometry problems. So here we go. How many grams are there in 3.82 moles of this molecule here called perigolol, C6H6O3? Well, we know that the units on this, when we calculate it, will be grams per mole. There is our that per mole there, that division sign says that's a conversion, grams per mole. So if we have 3.82 moles of C6H6O3, and we know that every 1 mole, and yes, you still need to write these, C6H6O3, you need to write the formulas too, is going to be equal to 126.12 grams. Again, that's just 6 carbons, 6 hydrogens, and 3 oxygens. Add them all together, and you get roughly 4 times that. You're going to get 400, I think, and 82, 3 sig figs, 482 grams C6H6O3. All right, next problem here has 2 parts. Calculate the number of molecules of Freon 12 in the sample here. Freon 12 is a refrigerant. We have 5.56 milligrams of Freon 12. So let's do part 1. 5.56 milligrams, and we need 1,000 milligrams per gram. And then for Freon 12, there are 120.91 grams of CCl2F2 for every 1 mole. So that's going to give us, let's make this a little bit smaller here. That's going to let us convert milligrams to grams, grams to moles, but we need a number of molecules, so let's just keep going here. 1 mole to get to individual molecules of CCl2F2. We need Avogadro's number, 6.02 times 10 to the 23rd molecules of CCl2F2. That'll give us 2.77 times 10 to the 19th molecules CCl2F2. Okay, so there's the answer to part 1. 2.77 times 10 to the 19th molecules. The first one, pretty straightforward. Using Avogadro's number again, we can bring that in anytime. The second one gets a little bit trickier, harder to do out of context, but it says how many atoms of chlorine are in the sample. So we look at this when we have the molecules, and we have to really understand the words atoms and molecules to see how do atoms relate to molecules. It's a really, really simple answer once we have this first part. You look at the formula, CCl2F2, and you say, okay, that's the molecule. How many chlorines are in there? Well, there are 2. So every one of these molecules gives me 2 chlorines. One molecule gives me 2 chlorines. So the simple answer is, here's the number of molecules we have earlier. If we just double that, that's how many chlorines we're going to get. So intuitively we can just say that one molecule has 2 chlorines. We can set that up with conversions too if we'd like. Trying to go back here. Okay, if we took this and made it a conversion, we've got our 2.77 times 10 to the 19th molecules of CCl2, and we can just simply look at the formula and say every one molecule of CCl2 F2 has 2 atoms of chlorine. Dimensional analysis lets me make any relationship I want as long as it's intuitive and it's accurate. There are 2 atoms in that molecule. We can calculate that as well. So you can go with the simple answer, you can go with the mathematical answer, whichever one you want. You just need to know how to define the words atoms and molecules. The second answer is going to be 5.53 times 10 to the 19th atoms of chlorine. Okay, so that's our answer to the second question, and again that 2.77 is our answer, times 10 to the 19th molecules is the answer to the first question.